welcome to the next lecture, and you recall that in my last lecture I told you very important things, that in any rotating machines linear motions to construct such a machine is difficult. You must have a compact motors. So, the consequence of that is you can have cylindrical type motors, and it will have two parts. One is called stator, another is called rotor. Rotor is allowed to move, and both these stator and rotor irons will carry some windings, and they are supposed to carry some currents because windings are there, and they will produce their own magnetic field, and that can be designated as south poles of stator, north pole of stator, SS, NS. Similarly, rotor south pole SR and rotor north pole NR, and it is eventually these two sets of magnet, they will interact and give you the torque to understand what is happening inside a machine. So, I will now today discuss one important thing, that is common underlying principle of operation of electrical rotating machines. For example, first I draw a very rough sketch so that you can understand. Suppose here is your stator, and suppose this up is under south pole from this to this. I will draw a very sketchy diagram, and this is suppose NSSS like this. So, this is this pole, and suppose the rotor is also having pole. Suppose this is say NR, and this is say SR. Windings I am avoiding, I know how to create such poles. Now, suppose it is in this position and there is a shaft here, and I am sure if I hold it by hand, the torque experienced by the rotor will be like this, and it will have a tendency to move in the anti-clockwise direction, because SR will be repelled by SS and so on. One of course, must not forget that the same torque is experienced by the stator, because SS experiences a force in this direction and NS also repelling force in this direction, but rotor cannot move. I have put that boundary condition. Okay. So, torque, same torque will be experienced by stator poles as well as rotor poles, but stator cannot move, and rotor, it is rotor which will try to move. Now, the question is, suppose in this position I am for the time being I am just holding the rotor, I am not also allowing the rotor to move, but I am sure at this point there is an electromagnetic torque in this anticlockwise direction, is not. Now, what I do, I release my hand and rotor is now allowed to move. What will happen? Rotor will start moving in this direction, it will go like this, but eventually what will happen is this is SS, this is NS, rotor will come in this position, NR, I am sorry, SR will come here and NR will go there, and when they will be aligned, as it is moving, SR is coming under NS. So, like this it has come here, and it is at this point you can easily see when the stator and rotor fields are aligned along the same lines, okay, no torque, nothing like tangential force it will be experiencing. So, we first note that for this torque, and what will happen, the game will be over soon, it will just move, it will come in this position, in spite of the fact there is stator field, there is rotor fields, both of the windings are carrying current, but no torque can exist now. No torque means no tangential force exists now. Therefore, one condition is the stator and rotor poles can if they are aligned along the same line, no torque will be produced, electromagnetic torque. Why it is necessary to produce electromagnetic torque? Because if it is a motor, you have to do some work. So, there will be opposing force, and that much opposing force must be created to have sustained rotation. Therefore, this is the situation. Now, the question is then what I will demand from this set of poles of the stator and rotor, so that rotor will be also rotating and a sustained torque of constant magnitude will be produced. So, sustained torque of constant magnitude is to be produced. Then what condition should I impose on stator poles and rotor poles? Let us examine it. It is very simple, but interesting at the same time. I will just simply now draw SS and NS here, okay? And suppose the rotor poles I draw like this, just by a line NR and SR, and it can move like this. So, obviously, at this position it will produce a torque, and it is needless to say that the magnitude of the torque depend upon this angle, how far it is, but nonetheless certain angle exists between these two, and SS and S are fixed in space. Forget about it. At this position SS and S, SR and R, rotor experiences a torque. Now, certain amount of torque is produced, but the question is, suppose rotor will move, rotor velocity is nr, rotor will move, and if I say that I want to the same magnitude of torque when it was in this position, now rotor will advance here, SR NR will come here, suppose rotor poles comes here, and stator poles, it was earlier here SS NS, and if I demand whatever torque it was producing at this instant of time, some time elapses, rotor poles comes here SR NR, then obviously once again same torque exists here, but the magnitude of the torque depends upon how far this SR is from SS. That separation has increased, I do not know. So, the magnitude of the torque in this position is different from magnitude of the torque in this position. Now, if I say that same torque is to be produced, whatever was here, same torque has to be produced here, then I will say that that is possible only and if only SS and NS has and NS has also moved by that time such that the angle between them, if it is alpha I call, this remains alpha. I am repeating. So, SR NR was there initially, SS NS in this position, and if I hold it, it experiences a torque in the anticlockwise direction. Now, some time elapses, SR NR, because it was experiencing a torque, it will come suppose in the horizontal position like this, and if you say SS NS was where it was earlier like this. If it is there, okay, still torque is produced, but the magnitude of the torque between this S s and S r and this S s and S r will be different, because the angle between them is no longer is alpha. So, if somebody says no, same constant torque is to be produced when it was producing here whatever torque, then the answer to that question should be, then you not only allow S r n r to occupy new position like this, also advance S s n s by such an amount such that the angle between these two fields alpha remains same. So, rotor will be rotating, but you must make sure that the relative speed between the stator field and rotor field must be 0. At this point, one important thing should be understood, which we are often forgetting. For example, suppose you have a rotor coils, cross dot current, and this will become N r and S r, is not? This is the field. Now, as you rotate the rotor coils, this field will also rotate. In this position, it will come, is not? So, it looks like the direction of the current in the, if the rotor itself is moving, the field along with it will also move. For example, stator poles, examine that S s n s, and I told you this S s n s can be created by two slots carrying current S s and N s. Concentrate on this. I am now telling on one hand that S s n s too should be moved by the same amount, and I am telling stator is not allowed to move, stator conducts are all stationary. Therefore, how this can happen? As N r S r moves, how S s n s will move? These are interesting and important questions to be answered, to be understood rather. The idea is, we will see after few lectures that your coils may be stationary and it carries current. So, it looks like it will produce a stationary magnetic field, but it is possible a stationary coils carrying currents will produce a rotating magnetic field. That is what the principle of induction motor is. Therefore, whether a coil is stationary, whether S s n s can be also made to move will be clearer, but at this stage what I am simply telling is, to produce sustained electromagnetic torque, you must see that stator field and rotor field are moving at same speed with respect to a stationary observer, such that the relative speed between them is 0, no matter in which position rotor is. The angle between this stator and rotor field, that must remain constant. Then only sustained electromagnetic torque produced. I really at this stage do not know how to achieve this. That is there. How to achieve this is a big question, no doubt. But what I am telling from physical consideration, that in any machines, be it DC machine, synchronous machine, induction machine, this thing must be happening. How it is happening? We will see after few lectures or so. Therefore, the first condition is the relative speed, you write down relative speed between stator and rotor fields. Between stator field, let me write like this, stator field and rotor field must be 0, with respect to some observer, with respect to say stationary observer. It could be any observer, with respect to a stationary observer, in order that steady means constant electromagnetic torque which I am denoting by T is produced. In order that steady electromagnetic torque T is produced. And why you want to produce a constant electromagnetic torque? Because the machine in the steady state has to run at constant speed and there will be machine will be loaded. So, there will be opposing torque. So, T must balance T L, the opposing torque T opposite, and so without doing much, these are the expectations out of a rotating machines. Unless it cannot do this, it cannot produce a steady electromagnetic torque, which is very much needed. Understood? And one should understand that SSNA should be advanced, and if you have a situation like this, and you are passing a DC current, SSNS has produced and NRSR is also produced some DC current. Therefore, this one SRNR, SSNS are produced by DC current. Then here the field SSNS cannot be moved, and that is why it made with this fate, that is okay, after some time things goes. Sustained electromagnetic torque is never produced here. But the important point is, we will see later that even stationary coils are stationary, they will carry some current and still it can produce poles which will be found rotating. That is a great achievement, and it was first pronounced by Nikola Tesla. That is, even a stationary coil can produce a rotating magnetic field. So, let rotor move, that rotating stator field will also move, such that the angle between these two will perhaps remain constant and give you sustained torque. So, one condition, so common underlying principle under this heading, one condition is relative speed between the stator and rotor must be 0 all the time. During transient condition, it may change, either it will accelerate or decelerate, that is steady state condition. I must demand steady electromagnetic torque is produced out of any motor. Another important thing is, that is pictorially I will say, if there is a stationary observer, he is not bothered, it is your problem, make your winding in such a way. If this is your, I will now draw it a much simpler diagram. If this is your stator field just by a single line, and if this is your rotor field, or write BS, write BR, stationary observer, and if both of them are stationary, stationary observer will be happy, okay, this machine can produce a steady electromagnetic torque. if you find stationary observer is concluding that with respect to him Bs is moving with some speed ns rps, he will say that Br is also moving with the same speed with respect to him, whatever speed he sees Bs, same speed he must see for Br, such that the angle between them is constant and it will have a rotating magnetic field. I hope you have got the point. Achha, another important point is there, that is the first I write that, then try to explain. The second important point is the number of poles of stator and number of poles created by rotor when it carries current. Number of poles of rotor must be same. This is a must. Number of stator poles, for example, in this example we have a machine where two poles are there, SSNS for the stator, and also two poles are there for rotor NRSR. Now, here is a new situation now, therefore, it looks like that we know how to create a two pole pattern, as I told you. For the stator you have two coils, pass current, cross dot, and SS and NS will be created. Similarly, for rotor you have two coils, pass some DC current, those two poles will be created. But how to create more number of poles for stator and rotor? That is the question, because it looks like number of poles should be same. And at this stage I must tell you, there are machines which we often call it is a two pole machine, it is a four pole machine, it is a six pole machine or eight pole machines. Mind you, the number of poles must be even. There cannot be a situation where 5 poles are created by a stator, because of the fact the lines of force you must give a sink for a north pole lines of force to terminate on a south of, not terminate, it must close its path via a south pole, lines of force coming, it must enter a south pole. So, number of poles cannot be odd, always even. Now, let us try to see how to create say 4 number of poles, very interesting. For example, you have a stator structure. Stator iron is there. Now, what you do is that you suppose have got a slot here, at 90° another slot, very interesting, and another pair of slots, not I mean there are 4 slots. Okay. Then what you do, listen carefully. So, this is the stator iron. These are open space, and what you do now, you place one conductor here, 1. I was writing x 1 y, henceforth I will write 1, the front side, and its return side is 1 dashed, and these 2 coils I will join at the back. Understood? Earlier what I was doing, here was a conductor, here was a conductor, these two at the back I was joining to have a series connection. Now, I am telling slightly different. Suppose you have 4 slots 90° apart, this is one, this is one dashed, and they are joined at the back. So, it gives you a coil, and this symbolically I now for the first time I will draw like this. Okay, you have a coil whose two terminals are 1 and 1 dashed distinct. Similarly, you have another coil, its front end is 2 and its return end is 2 dashed. Electrically, it is a separate coil, it has got its own identity, it has nothing to do with 1 dashed, no way, a physical coil here, a physical coil there. But for a change, 2 is not the return conductor of 1 dashed is the return conductor. Similarly, 2 dashed is the return conductor of 2, and just a simple way these two coils I can draw like this. Okay. Now, what I will do is I will connect them in series, these two coils, that I can do because those terminals are available externally to me. I will connect them in series, and I will connect a DC voltage, so that current I flows. So, how to show these currents here? Through the 1 of this coil 1 dash current is entering. So, it must be shown cross. Through the 1 dash current is leaving for this coil. So, I must show a dot here. For the second coil 2 dash current is entering through 2, therefore, I once again show it cross, and through the 2 dash current is coming out, I will show it dot. So, cross dot cross dot. Now, what is the implication of this? Implication is very interesting. See, this cross current will produce lines of forces like this. This dot current will produce lines of forces like this. This cross current will produce a lines of forces like this. I am just drawing two representative, and this 2 dashed will produce, this is dot current like this. So, it produces lines of forces like this, is not, this is the thing. Now, see this portion of the iron, lines of forces are entering. So, this 1/4 of this total iron will behave like a south pole, this inner face, of course, inner face, south pole. Look at this quarter, lines of forces are coming out from this inner iron of the stator. Therefore, this can be, this must be a north pole created. Put it SS1, NS1. This is similarly this one, this quarter here. So, there will be NS1 here, and this quarter it will be once again SS, and let me call it SS2, second south pole of the machine, and here once again lines of forces are coming out. So, this quarter will become a north pole. Therefore, I have now been able to produce 4 poles. So, ultimately what I have done is this quarter is your this south pole SS, this is NS, once again SS, and this is NS, If you want to distinguish between 1 2 you can name SS1, NS1, SS2, NS2, that will not be necessary. So, this is how I can make a full 4 pole arrangement. Okay. So, I will continue with this next time, that is the conditions that the number of poles must be same for both stators. What we have learned, that any iron body, stator iron body, similarly this is true for rotor iron body. Why not? That I can create any even number of poles if I wish by having appropriate coil display on the slots and passing current through them. Thank you.